Hello friends, this is the program solution channel on YouTube. Now today we are going to learn about the computer graphics 2D operations. In 2D operation we will see the transformation, scaling, shear transformation, rotation and reflection operation. First we will see the translation operation. In translation we actually move the object from one place to another with respect to x or y direction. Here in this image we will see the rectangle, which is the x unit away from the x-axis and y unit away from the y-axis. We have to move, suppose we have to move that rectangle by tx amount in x direction and by ty amount in y direction. Then we have to add this distance in the respective every coordinates of the this rectangle. The formula for that is this. In this, x and y represent the every coordinate of the rectangle. Tx and ty are the distance by which we have to move that object, and this is the resultant image. In this direction, in this diagram, this is the original image, and this is the translated image by tx and ty amount in x and y direction. Next operation we will going to see is scaling operation. In scaling we actually increase the size of image or decrease the size of image. Suppose here we see this is the rectangle. The length of rectangle is x unit and the breadth is y units. Suppose we have to increase or reduce the length or breadth of rectangle, then we use the scaling operation. Here we doubles the size of a rectangle. The initial length of rectangle is x, and the scaling, that is after scaling operation, the length becomes the 2x, and after scaling operation the breadth become 2y. So in this way scaling operation is run. We will see the scaling operation in detail. And suppose this is the original image, this is the scale image by sx amount in x direction only, and this is the scaling image in y direction only. Suppose we have to scale the image by both direction, then we use the sx and sy direction only. For the scaling operation we use the formula. This represents the every coordinate of the rectangle. This represents the scaling matrix, which is the 2 by 2 matrix. This represent the sx represent the amount by which we have to scale the x coordinate, and this represent the amount by which we have to scale the y coordinates. This is the resultant image. The next operation we will see shear in shear transformation. We actually move one part of the image by respect to x and y direction by specific unit. Here we have performed the vertical shearing, and here we have performed the horizontal shearing. In vertical shearing we have moved this BC side by in vertical direction, that is according to y direction, and in this we have moved the DC side in horizontal direction. The next operation we will going to see is rotation. In rotation we actually rotate the image in x in anti-clockwise direction or in clockwise direction. In anti-clockwise direction we have to move the image in specific with respect to the specific point. Here we have rotated the our triangle by origin, about its origin in 90 degree in anti-clockwise direction. The formula for that is here we have shown. Here x and y are the coordinates of the triangle, and this is the formula for that. Here the @ represents the angle which is in radian, which is the most important thing in rotation operation. The next suppose the next operation, in this way we have see that the rotation operation about its origin. Suppose we have given the image which is not present at the origin, then what we have to do? In this case we have to transfer that one point of the image to origin, about which we have to rotate the image. Then we will rotate the image, and again transfer the image back to its original position. Then we will get the rotated image about that arbitrary point. Next operation is reflection. In reflection, we actually apply the mirror image. That is, this is the original image. We have got the reflected image about the y-axis. Suppose we place the mirror here, then we get the image like this. This is shown in the reflected uh, operation, reflection operation. The formula for that is this. The xy represent the coordinates of the image. Here we have taken only dot, but you can take a line or a rectangle or anything 2D image. Next operation, suppose in this case we have moved the image only in x and y direction. Suppose we have to move both direction, then we have to reflect the image about its origin, that is both x and y direction. Here in this diagram we have seen that this line is reflected about its origin. For that we have to apply first x axis reflection and then again y axis reflection. Then we will get the image which is reflected about its origin. Hopefully you will like this video. Subscribe our channel, that is program solution. Hopefully we will meet in next video, that is 2D program. Have a nice day. Thanks a lot.